This is Food Chemistry Unit 1, Chapter 22, Food Packaging and Labeling. Packaging. All methods of food preservation rely on some type of packaging. Canned, frozen, and dried foods all need to be stored in suitable containers to maintain their quality. This is so essential to the food industry, there's a degree in it known as packaging engineering. Packaging materials are regulated by the FDA. Any package that touches food is now an additive. You have two types of containers. You have your primary container where food is in direct contact with the package, like the carton of milk. The milk touches the carton. Then you have your secondary container that holds the primary container. So look at the cereal here. The cereal itself is in a package. That's the primary container. And then that bag is in a box. And that box is the secondary container. Functions of packaging. The main function is it acts as a barrier between food and contaminants, such as moisture, gas, odors, and light. It protects food from impact during shipping. It acts as a dispenser. It allows the consumer to use what is needed, close the package, and reuse it later. The package is used for identification of contents. That's your labels. Some are used for storage or cooking or serving. This would be your microwave dinners, something like this. There's hermetic packaging, so the container is completely sealed or airtight, so water, vapor, gases, and odors cannot enter or leave. This is your canned foods. And then some packages are ventilated. These are your refrigerated doughs, like the cinnamon rolls here. If you've ever opened one of these packages, it makes a lot of pop. So they release carbon dioxide. This package would explode if it was not ventilated to release some of that gas. Types of packaging materials. It depends on the function needed. It depends on how it will be shipped. Depends on how food is preserved. And it depends on the chemical content of the food. Some coatings might react with highly acidic foods during canning. So let's look at metals. The three most common are steel, tin, and aluminum. Steel is inexpensive, easily shaped, and can form that hermetic closure. Iron and carbon actually make up steel. It's not on the periodic table. It's a combination of iron plus carbon. Cans are usually coated with enamel or resin because steel is corrosive. That's where tin comes in. Tin, there's a thin layer of tin coating on steel cans. Tin is stable longer, it's less corrosive, and this is how the tin can got its name. But really only 0.25% of a tin can is actually tin. So it's really just the coating. Aluminum. Aluminum is lightweight, stable against corrosion, and easily shaped. But that lack of structural strength limits its use in the canning industry, but you probably know it as aluminum foil. It is costly, but it is recyclable. So here's your steel cans. You can see the inside is coated with that tin, and then you have the aluminum packaging right here. Glass. Glass is chemically inert, which means it does not react with food. It won't contaminate food. It's transparent and recyclable. But it is easily breakable though, especially with temperature changes. Scratches lead to breaks, so glass is often coated with wax or silicone, and it's also heavier, so that increases the shipping costs, which increases the consumer price for the product. Paper. It's lightweight, has a low cost, and is recyclable. If combined with plastic or aluminum, it can form that hermetic seal. Paper that touches food must be free of chemicals and contaminants. It's usually coated with wax, plastics, aluminum, depends on the food and the use. So you can see a couple of products here that are packaged with paper. Plastics, lightweight, economical, and versatile. Polymers, copolymers, and ionomers are basically long chains of molecules of the same compound. That's what makes up your plastics. Packaging films, these are thin, flexible, transparent materials. Cellophane might sound familiar to you. It's specially processed cellulose, and there's over 100 types. And cellulose is a plant material. There's various levels of permeability, so what liquids and gases can pass through the film. You have your edible films and coatings. So there's a specialized type of film that's edible, such as a rice paper wrapper, which often covers seaweed candy, which I believe I've got an image of right here. Yeah, there you go. Films are often layers or sheets. They're made from starch, protein, animal intestines, like your casing for sausages right here. Coatings are often liquids such as wax or oil that food is dipped in or sprayed onto the foods. It's used on hot dogs and sausages for shape. It's used on cucumbers to protect them. Sorry, typo right here. They're used on cucumbers to protect from mold. I was wondering what I wrote there. Sorry, had to fix that. But this is a fun one. If you eat Raisin Bran, the raisins in your Raisin Bran cereal are actually sprayed with starch. That's not sugar, that's starch to hold the moisture of the raisins so they remain a little bit chewy. Isn't that neat? All right, lemonades. These are several layers fused together. These are your retort pouches that you might see for the U.S. military. This replaced metal cans. The retort layers are polyester, aluminum foil, and a polypropylene film for the seal. The retorts, you can see these right here. These are your meals that are ready to eat. They withstand high temperatures and pressures, which is needed for the military, right, for their different locations. So you can see the package of food in there, right? Reduced oxygen packaging. This is an atmosphere with little or no oxygen, and research shows that this extends shelf life. So red meat, poultry, seafood, pasta, cheeses, pre-cooked meals, snacks, and dried foods can use this. Fresh chilled foods are now on the market. These are your fresh pastas and sauces that were developed from this technique. So this has been around for a while, the meat, but this is relatively new. So now you can have your pastas that are already cooked in this package right here to help keep them fresh. CAP, this is controlled atmosphere packaging. Components of the packaging material may absorb oxygen released from the product or react with the product. This extends the life of fresh produce. So I do show this in class. So apples should not be seasonal, right? Like they only are around when the apple tree produces the apples, right? But what happens is you can extend the life of those apples. If you have an abundance of apples, you can put them in this controlled atmosphere setting that basically slows the ripening process. So take a look at these two videos. You can see this is a commercial for the apples themselves, and then you can see how they're stored. So you're reducing the gas that surrounds the apple, right? So you take the oxygen out, you put some like nitrogen in there, and it basically kind of puts them to sleep and slows the ripening process. All right, MAP, this is a modified atmosphere packaging. So this is a one-time flushing of a container with gas, like potato chip bags, right? So if you ever wonder why there's so much air inside, you open them up and there's like, half the bags filled with the chips. I think there could be more in there, but like why they filled that way? They're filled with CO2 or nitrogen. Same concept as the apples, right? It prevents the chips from being crushed during shipping and kind of keeps them a little bit fresher longer, but still think there could be more in there. All right, and biodegradable packing and bioplastics. So biodegradable packing, PLA is polylactic acid, degrades within a year in a landfill, and it turns it into CO2, carbon dioxide, methane, and water. It's made when bacteria ferment starchy foods like corn, beets, potatoes, and wheat. Could be used for sandwich bags, deli containers, or lining hot beverage cups. So this is still in the works right here. This is not common right now, but it's being looked at. Bioplastics, food waste like vegetable stems, rice hulls, cocoa pod husks could be turned into cellulose-based plastics. Consumers are not always happy with biodegradable options. Many companies are continuing to work on this. People are just uncomfortable with them. Not sure why. I don't have a problem with them, but really it is just preference. So this is an area of research that still being developed. I think it's needed, but people are still looking at what consumers will and will not purchase. So companies are still working on it.